Alright, welcome. So today Academic Dad will be teaching you everything you need to know with regards to solving questions that involve gas laws. So here you have it, an unknown gas, let's say X, and chlorine, that is CO2, are in the ratio of 6 is to 5. 6 is to 5, that is in the ratio of 6 is to 5, that is 6 over 5. Assuming the density of chlorine to be 36, calculate the molecular weight of the unknown gas. So this ratio means the rate of diffusion, and looking at this automatically, density is equals to mass over volume, which means that as mass is increasing, density is increasing. This means directly proportional. So this is the sentence saying that the molar mass is what they're talking about here, is 36. So if molar mass is 30, if the mass is 36, and we know that chlorine exists as Cl2, it simply means that this is the sentence as 36 times 2. Understand? And if you do 36 times 2, this will now give you 72 gram per mole. So if you know this is the sentence using Graham's law of diffusion. It says that the rates of diffusion or rate of effusion of a gas is inversely proportional to the square root of the molar masses apart. So this is his law. Sometimes it's stated as equals to T2 over T1 as well. So this means that this is now square root of 72 for, okay, watch. An unknown gas and chlorine is in the ratio of 6 is to 5. Okay, yes. So unknown gas is the sentence as R1, and R1 is the one carrying M1. Yes. So R2 for chlorine 5, and is the one carrying M2. So we are correct. So let's call this the X. So in this case, trying to make X subject of the formula means we divide both sides. Trying to make X subject of the formula means we have to take the square of both sides. So, or you say when the square will cross equality sign, this is something as 6 over 5 all squared, then 72 over X that's taking the squares, cross multiply, so that I have 36 x equals to 72 times 25. So this is the sentence 1836x. So trying to make x subject of the formula means we divide both sides by the coefficient of x, which is 36. So if we divide both sides by 36, we now have that this is 50. So x is 50. The molar mass of x is 50. Molar mass is the same thing as the molecular weight. So it's 50 gram per mole. This is our answer. So there you have it. Let's move to the second question. So number two question says, how many grams of CO2, that is carbon 4 oxide, should be placed in a 250 milliliter container at minus 24 degrees Celsius to produce a pressure of 95 kilopascal? That's the question. That's the question. Number 2. Everything. So this is the interpretation. This is the interpretation. So we have, there you have it. Now I need you to know that at STP, volume is liter, temperature is 273. So we must convert this to 273 Kelvin. Then milliliter is liter, so we must do 250 milliliter. Milliliter to liter simply means divide by 1000. So this go here, this becomes 0.25. Now that you know this, now converting temperature to Kelvin, degree Kelvin, means that this will now be 249 Kelvin. This will be 249 Kelvin. That's what you get. Then kilopascal, you need to know that at STP, pressure is in atm. So I also want to teach you this. 1 kilopascal at atm, 1 kilopascal is 101.3 kilopascal. 1 pascal is 101.325 pascal at STP. All at STP. Okay, at STP, I've already written it. All at STP. So at STP, torr is 760. At STP, millimeter mercury, these are units of pressure, is 760 millimeter mercury torr. So what this thing means is that anytime you are given any value, for example, you're given any value, let's say you're given 20 kilopascal. To convert it to atm, simply divide this by this value. Example, let's say I have 20 kilopascal given to me in the question. I need to convert it to atm, which is the SI units of pressure at STP. All I need to do is to simply do 20 all over 101.3 kilopascal. Then I will get my answer in atm. Whatever answer I get is in atm. The same thing applies to when I'm giving in pascal. If I want to convert from pascal to atm, let's say the value I'm giving for pressure is 10 pascal. To convert to atm, I'll do 10 all over 100 and 10,100 and how do I even put it? Okay, I'm pitting this value. This should be 101,325 pascal. So once you know it, now when I'm giving a value in torr, let's say I'm giving 20 torr as the pressure. To convert from torr to atm, simply do, let's say if I'm giving 20 torr, I'll do 20 divided by 760. That's the atm. If I'm giving a millimeter mercury, I'll do 760 millimeter mercury divided by 760 millimeter mercury takes it to 1 atm. Any of this you divide by itself, just as it's standing like this now, is equals to 1, and that is 1 atm. So to convert, just divide by its factors here. So now that you know this, I also need you to know how to convert to, for example, from pascal to torr. So from pascal to torr, simply divide the value you are given by 133.3. Now if you want to convert from torr to atm, I've already said that. Okay, let's say you are converting from torr to for example, torr to kilopascal. From torr to kilopascal, all you need to do is just divide by 7. I just want to believe I'm correct. So just divide by 7.501. Now if you want to convert from kilopascal to torr, just do the reverse. From torr to kilopascal you divided, so from kilopascal to torr multiply by 7.501. Now from kilopascal to atm, you already know you divide by 101.3. So if you want to convert from atm to kilopascal, that means you multiply. So there you have it. So with that said, let's go back to solving our question. So that means that for this particular question, for us to solve this particular question, what that means is that we simply need to get to the part where we'll divide this by 101 points. Okay, wait, was he given in Thor? Yes, 101.3 kilopascal. So once we do this, this will cancel out, so that I now have that this is equals to ATM is the S1 unit, so the standard unit. So this is now going to give me 0.9378 ATM. So the minute I'm through with converting these values, I will now remember that everything I'm given has P, I have V, I have N. Shebi? Okay, I'm told to find how many grams. Okay, I don't have any. That is why I'm using this formula, because I want to find gram, and gram is equals to mole times molar mass, but I don't have mole. I need to find mole. Then R is a natural gas constant, so which is 0.0821. Then I have my temperature given, so that if I make move subject of the formula, I will have that this is PV all over RT equals to N. So substituting, I now have that this is the same thing as saying 0.9378 times 0.25 all over 0.0821 times 249. So that by the time you punch it, you have that this is the same equals to N mole. By the time you punch it, you have that this is the same thing as saying 0.23445 all over 20.4429 equals to N. So by the time you punch it, you have that N is equals to 0.011469 mole. So now that you have your mole, use what you have to get what you don't have. So to get mole, remember the question is how many grams of CO2 should be placed in a 250 milliliter container. So we have mole to be equals to 0.011469, and CO2, the molar mass of CO2 is the same thing as 12 plus 16 times 2, which is the same thing as 12 plus 32, which is 44 gram per mole. So since we know that mole is equals to mass over molar mass, we have mole, we have molar mass, we are looking for mass, which is gram. This is the same thing as saying 0.011469 times 44 gram per mole equals to mass. So this is mole, this is gram per mole. So this is over this. So when the times this and this will cancel, so that I now have multiplication will now give me that mass is equals to 0.5046 gram, approximately 0.5 gram. So this is my answer. This is my answer. It says 1.5 mole of argon gas is placed in a container at 27 degrees Celsius at a pressure of 725 torr. What is the volume of the container in milliliter? So mole is 1.5, temperature is 27 degrees Celsius, which is the same as plus 273 Kelvin, which will give us 300 degree Kelvin. Then pressure is in 725 torr, and 725 torr simply the same thing as saying 725 divided by 760 to give you the ATM value. So 725 divided by 760, you get the ATM value, which is going to be 0.9539. Then they are asking us what is the volume. What is the volume in milliliter? So they gave us mole 1.5, they gave us temperature, we've converted it to Kelvin, they gave us pressure in torr, and we've converted it to ATM. So they're asking us what is the volume. That's the question there. So to find the volume, we need to make use of what we have. And make use of what we have, we see that we have P and we have V. We don't have V, then we have N, then natural gas constant 0.0821 is a constant, is always there. Then we have T. So making V subject of the formula, we have that this is the same as dividing by the coefficient of V, which is P, nRT over P. This will cancel this, so that V is equals to 1.5 times 0.0821 times 300 all over pressure is 0.9539. So that when you do this, when you do the punching, you have that this is the same thing as 36.945 all over 0.9539, and this is equals to, this is the V is approximately equals to 38.7305. But you know that whenever we do our mathematical calculations of PV and equals to nRT, whatever you need to have for volume is in liter, but they say we should leave our answer in milliliter. So to get it in milliliter is the same thing as saying 38.7305 times 1000 to get the milliliter. So when you punch it, you have that this is 38,730.47 milliliter. So this is our volume. This is our volume. This is our volume. So taking time to analyze what we've done so far, so good.